Okay, let's give you guys a vector problem. So here you've got a parallelogram. A, B, C, D is a parallelogram, and X is a midpoint. X is the midpoint between A and B. So this vector here from A to D is called A, and this vector here from A to B here is the vector B. So find the vector AE, so that's this vector here, A to E. So find this vector in terms of A and B. So press pause and have a go. Okay, so to do this, the first step is to find the vector from A to C, and then it's going to be some scalar multiple of AC. So the first step is to find this vector AC, and then it's going to be well, according to this diagram, it's probably about 0.3 AC, and then find the vector. See this vector here, dx. It's going so find the vector dx. So find the vector dx. So that's this vector here, and then it's going to be some scalar multiple of that vector. So let's just imagine it to be 0.7. So we're going to have two paths. One is going to be, well, AE is going to be this vector here, which would be A, and then you would go down some sort of scalar amount. Let's call it plus K, and then find the vector A, find the vector dx. So let's start again here. Hang on. So we are going to find two ways to get from A to E. The first step is to go up here and then down. That will then give us one equation, and the other one would be to find this vector here, to find this vector AC, which is going to be across here, which is B, and then up here, which is A. So we know this vector here, and then it's going to be some sort of multiple of that thing. You see what I mean later. So let's start again. The first step is to find AC. So the first step is to find this vector here, A to C. Well, the vector A to C is you moving up A, which is this thing here, and then across B, which is the same as this because it's a parallelogram. So we know the vector AC. AC is given by A plus B, and then it's going to be some sort of so we know this vector AC. So we know it's going to be some sort of scalar multiple of that vector. So in this diagram, it's probably 0.3, roughly around there. And then the next step is to find the vector dx. Find this vector here, which is given by us going. So imagine you're an ant and you're here. You've got to go back A. That's why it's a negative A here, and then across B. But remember, B is from A all the way to here, but you want half of that because you're told in the question that X is a midpoint between A and B. That's why you've got this half here. So we know this vector dx, which is given by this thing here. So the vector AE is given by us moving up here. So we're moving along up here, which will be A, and then, well, we know the vector dx here. Dx is given by this thing here, which is this thing here. But then it's going to be some sort of scalar multiple of this, or of the vector dx. So that's why we stick an m in here. In this diagram, you can imagine m as being 0.7. It's part of the way, it's part of dx. Well, anyway, we've got two paths. Looking at this vector here, which is this thing here, it's going to be some sort of scalar multiple of that vector. So that's the direct vector from A to E. And then the other one is us moving up here and then down here. It would take us to the same place. So really we are looking for K and M in such a way that this thing here equals this thing here. So the next step is to set these two to be the same as each other because they're both taking us to the same place. Our job is to find a number here and a number here where the two will be equal. So our next step is to set this to be the same as this. So set the two to be the same as each other. So this thing here is this thing, and this thing here is this thing here. So remember, our job is to find K and M in such a way that this side equals this side. So let's just tidy this up. This times this will give us this. This times this will then give us this. This times this. This times this will then give us this. So now, hang on. So now remember, we are trying to find m and k in such a way that this side equals this side. So let's group all the a's together. So you've got a vector a here, so you can factorize it to this, and this here stays the same. Remember, you're trying to find m and k in such a way that these two are equal to each other. Well, if you look at the vector a, the component of vector a, so look at this. If you want the two to be the same, then you've got to demand that this is the same as this. So looking at the two components of a, demand that these two to be the same as each other. So that's these two here. And then also demand that, well, looking at the b component, demand that these two to be the same as each other. That will then give you this. So looking at this, you demanding m and k in such a way that this side equals this side is the same as you trying to find m and k where it will satisfy these two. So now looking at this, we can, well, if k equals this thing here and k equals this thing here, so these two must be the same as each other. So let's set the two to be the same as each other. So in a way, we've in effect eliminated k. So now rearrange it to find m. So m turns out to be this. So once you know m, you can go back to here and work out k. Well, m divided by 2 will give you k. So looking at this, 2 over 3 is m divided by 2. It gets multiplied to the bottom, so it will give you a third. So k equals a third. So now we know m and k. So now we know m and k. Well, if you look at this thing here, if k equals a third, so remember ae is given by you putting a third into here. So what that means is going to be a third of a. So a is from here to here, so a third of a is you moving a third of the way up. So let's cut this up into 3 equal pieces. So a third would be you moving up here by a third, and then a third of b. Well, b is all the way across here, cut up into 3 equal pieces. Hang on. Cut up into 3 equal pieces. So you can see when you put a third into here, it's you moving a third up a, so that's up here, and then a third up, a third across b. So that would then take you to E. Or if you want, you can use this. Put 2/3 into the M here. So what that means is the vector AE is you moving up A. So you moving up A, that will then take you to here. And then remember 2/3 of negative A. So negative A is you moving down in this direction. But then 2/3, well, let's cut this up into 3 equal pieces. 1, 2, 3. So you moving, when you put 2/3 into here, it's you moving 2/3 down. 1, 2, and then 2/3 across. Well, 2/3 times this would be when you put 2/3 into here, and then you times a half b, that would be a third across in the b direction. So cut this up into 3 equal pieces. So you moving a third in the b vector would take you to the same place. Well, anyway, the vector AE, well, all you have to do is put this into here and then put this into here. So you can either use this or you can use this. This is simpler. So put a third into here. So that would be a third, and then A plus B. So this is your answer. You could use this, but this looks ugly. Okay, so use this. So this is your final answer.